So paging and segmentation. These are memory management techniques done by the operating system to split up your program. So you have a program, right? Now this could be Netflix, for example, because you've downloaded the Netflix app on your phone or computer. And in the Netflix program is the Netflix code. So this could be a function for display. And this is going to be the code to display your video to you. And there are other functionalities and data in here. But where does this need to go? Where does your program need to go to be able to be ran and executed by the CPU? Well, it has to go in your memory. For example, RAM. But what happens if your program is larger in size than your available memory on your computer? Well, this is where the operating system comes into play. And the operating system is going to split up your program so it's more manageable. And it's going to do that in either two ways. One is paging. And the other, as you can guess, is segmentation. So what is the difference? So paging is when the operating system is going to split up your program, so your 6 gigabytes program, into equally sized pages containing various parts of your code, of your program, and the data. So equal sized fixed pages. Now segmentation, on the other hand, is going to split up your program in a more logical way. So it's going to split up into different segments. So this is going to be the code segment, which will contain all of your code for your program. You'll also have a data segment, and this will contain all of the data in your program. And you can have a stack segment as well, which will contain your local variables in your functions, amongst other things. But the difference here is that the sizes are not equal. So this code could be 3 gigabytes, your data can be 1 gigabyte, and your stack can be 2 gigabytes. Now in the end, they will all equal 6 gigabytes, which is your program. But the difference is they are split differently. So let's now take a look more deeply in terms of how this splitting is happening. So here is your program, okay? And it's got various different things. It has G as a global variable. It also has your functions and some variables within those functions. And the functions are being called down here. Now, depending on whether we use segmentation and paging, as we discussed, they will be split differently. So remember, segmentation is split logically. So here we have your local variables, which are inside your functions. Now these will be placed within the stack segment, okay? We also have a global variable that will be placed in the data segment. And we have inside the code segment the actual code in machine code. And now let's take a look at how paging splits up our program. So as we can see, we have the code for the foo function in page 1 and the code for the bar function in page 2. Here is foo and here is bar. Now take a look at how segmentation did the split. It put both the code in the code segment. Okay, so we have two separate segments, or two separate pages rather, for the code for different functions, whereas we have one segment when using segmentation. So let's take a look at what our program looks like in memory when the operating system uses segmentation to divide our program into segments. So we have our program Netflix, but let's say before running our program, we were running another program, let's say YouTube, because we downloaded the YouTube app. And let's say that the code, data, and stack for YouTube was split up like this, where the code gets 1 gigabyte and the data gets 2 gigabytes and the stack gets 1 gigabyte. So this is YouTube, Y for YouTube. And in memory, this would be allocated as such, where each block is 1 gigabyte. So the code will be here and our data will take 2 gigabytes worth of our 6 gigabytes of memory, and the stack takes 1 gigabyte. So let's now say that our YouTube program no longer needed the data, so the data segment, so that becomes free. And now we want to run our Netflix program, but now we have 2 gigabytes of space here and 2 gigabytes of space here. So if we were to allocate, say, our code for our Netflix program, we could put that here, or we could put that over there on this side. But the main issue is, how are we going to allocate our stack, which takes 3 gigabytes? Even though we have 2 gigabytes here and 2 gigabytes here, which means we have 4 gigabytes in total, the issue with segmentation is that it requires a contiguous block of memory. So a contiguous block of memory means a clear run. It needs a clear run of 3 gigabytes, which we don't have. And this is what is known as external fragmentation. Now let's take a look at paging and how the pages are laid out in memory. So let's go back to our YouTube example, but remember this time, because we're using paging, it's fixed equal size blocks. So we have 2 gigabytes here and 2 gigabytes here, page 1 and page 2. So let's say this was one part and this was another part of YouTube. 2 pages, page 1 and page 2. And then we say we no longer need this page. So this becomes free. And now what we can do is we can put any 2 pages from our Netflix program in here. So let's say we need pages 1 and pages 2. And as you can see, there is no external fragmentation because we're using fixed size pages. We can efficiently allocate memory. However, what is the issue with paging? The issue is because it's fixed size, we may be having internal fragmentation, which is where we have wasted space within our pages. So take a look at this. We are only storing one global variable, but because we need fixed size pages, we may need to add some padding. And so how does this look like in memory? So this is still page 2, and we have g equals 3, and we have padding. Remember, this is still one page. However, this is now wasted or externally fragmented, this part here, because we did not need this padding, and we could have kept this 1 gigabyte free. However, because we're using paging and we allocate fixed size blocks, even if we just need one variable, we have to put the whole page in. So this is called internal fragmentation. And internal fragmentation is wasted space within our page, as you can see. So you can see the difference between segmentation and paging. Segmentation is nice and clearly logically separated. However, this leads to variable sized segments, and so we could get external fragmentation, as the requirement is we need contiguous blocks of memory for our variable sized segments. Paging, on the other hand, does not result in external fragmentation, but because we're allocating fixed pages, even if we only need a small part of our page, we need to allocate the whole page. So we have internal fragmentation.